will be the welcome and the introduction from Ms. Mariana Lagonikou from Resos branch, that they are the coordinators of FRIETS Marie Curie Rise project. So Mariana, the floor is yours.
Thank you, Sophia. Good morning, everyone. As Sophia told, my name is Mariana Lagonikou, and I am the project coordinator of the FRIETS project on behalf of Resos branch. It's my pleasure to welcome you to today's webinar, which aims to explore the challenges in the berries value chains and present innovative solutions developed by both FRIETS and collaborating projects. Before we begin, allow me to share a few words about the FRIETS project. FRIETS is a Marie Curie project that started in September 2021 and seek to provide innovative solutions and meet the global demand for functional and healthy snacks. The FRIETS consortium consists of 13 partners, 6 universities, and 7 small and medium-sized enterprises spanning five European countries: Greece, Malta, Cyprus, Romania, and the UK. Our ambition in FRIETS project is to pave the way for the development and commercialization of functional, personalized, and nutritious soft fruit snacks, offering an attractive way to increase daily fruit consumption. We focus on strawberries, blackberries, raspberries, and blueberries that contain no added sugar, sodium, or chemical preservatives. To achieve this, we are optimizing pre-harvest management practices for high-quality berry cultivation. We are optimizing low-impact post-harvest technologies. We use drying techniques like osmotic dehydration and freeze drying. We are also creating edible coatings for micro and macroalgae components, incorporating encapsulated or non-encapsulated natural functional ingredients. Finally, we are conducting LCA life cycle analysis and socio-techno-economic analysis to ensure the sustainability of the FRIETS final products. The project offers a valuable opportunity for the staff involved in order to enhance their potential and open new career development pathways. Resos branch is proud to coordinate the FRIETS project, and we look forward to working together for a healthier and more sustainable future. Today's agenda is structured to cover key aspects of innovation and collaboration in the agri-food sector. Let me share the agenda. Can you see my screen?
Yes, yes.
Okay, thank you. We will start with a keynote presentation by Professor George Manganaris from the Cyprus University of Technology. Next, we will highlight FRIETS innovation, focusing on precision agriculture, the hydration processes, and edible coatings. Representative from the Agricultural University of Athens, the University of Agricultural Science and Veterinary Medicine of Cluj-Napoca, as well as the National Technical University of Athens, will provide invaluable insight in these fields. Following this, we will introduce 3 collaborating projects: PrimeSoft, Ria for Food, and Sakami, each making their own contribution to the agri-food sector. The webinar will continue with a panel session led by Dr. Sofia Papadaki from Dignity, and finally it will conclude with an interactive Q&A session. So I think that we can start. Sofia, please.
Of course. Now, the second part of the webinar will start, starting with a keynote presentation of Professor Manganaris from Cyprus University of Technology, dealing with challenges in the berries value chain. Professor Manganaris, the floor is yours.
Thank you very much, Sophia. for the presentation. The title of my talk is to provide you challenges in the value chain of berries, considering the fact that berries are of high quality, but at the same time they are highly perishable crops. The three pillars of my talk today, I will introduce myself for those who are not familiar with my area of expertise, and then I will move to the main part of my talk. Well, I will try to describe with some examples the berry fruit production sector within a global context. What is the current status? What are the consumer perceptions about consumption of berry crops? And what are the challenges and the limitations? And I will conclude how the industry needs can be met and also the consumer's expectation, focusing in three case studies: strawberry, raspberry, and blueberry. I am a director of the Fruit Sciences group at Cyprus University of Technology. The website of my group is fruitsciences.eu, where you can find all relevant details about objectives, members, projects, facilities, protocols, courses, conferences, and publications that we have delivered. Our overarching objectives of my group is to try to optimize production systems practices, to incorporate post-harvest applications in the supply chain of the fresh produce, to characterize and valorize indigenous cultivars, to identify market opportunities, and to create interest, raise awareness among policymakers, and attract funding. Soft fruits or small berries represent a very diverse group of fruits with an exponential growth due to the fact that they have highly appreciable qualitative attributes, they have proven health-promoting properties, and there are several advancements in the production systems. As you can see on the table on the right, each crop, strawberry, raspberry, blueberry, belongs to different genus. So they are very different among them. They are small fruit crops. The consumers have the perception that they are more or less similar, but their production systems is quite different. And they received a lot of attention over the last 20 years due to the fact that although they are small crops, they provide large benefits for the consumers. At the same time, I would like to highlight that from an agronomist perspective, these two cultivations are very expensive cultivations in terms of production cost. Just to give you an idea, if you want to cultivate 1 hectare of raspberry, you need to invest approximately 130,000 euros. This is so high partially due to the fact that the plant material cost is having royalties, so you can purchase a single plant from 1 up to 3 euros. And also the labor efficiency is very limited. It's a small crop, so a worker can harvest only 20 kilograms per day. This is more or less the case with strawberry. Of course, the annual production cost is quite lower in that case. You need about 65,000 euros per hectare for an intensive setup. The plant material, depending on the cultivar, is spanning its cost from 0.18 up to 0.27 euros. And here the labor efficiency is about 150 kilograms per working day. From this crash test, what I would like to highlight is that these two cultivations are of high risk, and of course they are knowledge intensive investments. At the same time, if you are knowledgeable and you do everything appropriately, there is a big margin to have high returns back. The reality today about the berry fruit production sector is that there is a problem with labor availability, and also the labor cost is going sky high. The very high yield new cultivars deriving from breeding programs have high royalties. For that reason, you have to pay every year quite a lot of money to receive new plant material. It's highly perishable commodities with limited market life. And at the same time, we have issues with irrigation, and also there is an exponential growth of transportation costs if the plan is to export these crops abroad. The challenges are that we have to secure high yield efficiency. We need to extend storage potential. It's very important to have availability throughout the year. Definitely we'll have peaks for specific calendar days of the year, but it's very important to have availability, if possible, 12 months per year. And of course, the consumers and everyone is looking for sustainable production models. And also another challenging issue is how we can take advantage and exploit second-class products. I mean, fruit crops like strawberry that are of inferior quality. Some interesting facts. Here you can see a blackberry, and the picking speed is highly dependent on the fruit size. The bigger the size of the fruit, the bigger the efficiency of the picker. At the same time, please note that in order to produce a single berry, you need approximately 2 liters of irrigated water. This is another very challenging issue that you need a lot of resource also in terms of irrigation. Labor cost is a big issue, as I mentioned before, and here I have a comparison between the United States, that is a big player into the global market, and Serbia, that is the most important European country in terms of production volumes of raspberries. On the left of my slide, you can see mechanically harvested raspberries. All these raspberries are being destined for processing throughout the well-known individually quick frozen procedure. While on the right, again, the raspberries are mainly, almost 90% in Serbia is being intended for processing, but here you can see a different setup. You see workers into the farm harvesting by hand, and of course this means quite more expensive labor cost. A big challenge is to try to serve and offer fruits throughout the year. On the left, you can see a plan of raspberries that is being applied in Italy by a company located in the southern part of Italy, in Trento area. This company, Sant'Orsola, is having different cultivars of raspberry in different regions from south to north, different setups in order to be able to deliver into the markets from September until August. So as throughout the year, raspberries to be available into the retail markets. This is more or less the case for blackberries, and here there are two pictures that I captured from a field visit from a conference that I attended in the United States 2 years ago. You can see blackberries from two cultivars that are being harvested from July until October. And these cultivars are being harvested by Mexicans. So the interesting issue here is that this crew, the Mexican crew, after this 4-month period in the United States plus 2 months for preparation, they move and they settle to Mexico because there the conditions then change, and they produce and cultivate the same cultivars in Mexico area in order to have also year-round availability. And at the same time, they spend half the year in the United States and half of the year in the Mexico. So there's another trend to have experienced crews moving from one place to the other, because they have the know-how and the capacity how to cultivate and grow this, as I indicated in the previous slides, highly intensive production setups. So the key message from this slide is that we need to have a combination of cultivars, techniques, and plantations in different mesoclimates. It's also very important to define what we consider as premium quality berries. An issue is that we need big size. Big size is very important because we increase the labor efficiency in terms of harvesting. But the question is, would the consumers pay a premium for jumbo raspberry or a jumbo blackberry? There was a survey about that, and it was found out, yes, the size counts, but not more than 57% of the consumers preferred the super high sized fruits. So the big fruit size is important in terms of efficiency of the picker rather than in terms of quality for the consumer. The other interesting issue that is becoming very apparent in some retail markets is that there are consumers that do not seek for a blackberry, a raspberry, or a strawberry. They look for particular quality attributes. For example, in the case of blackberries, there are some companies that they promote sweet blackberries. I mean, blackberries that they have high soluble solids content and reduced acidity. This is the case also for some well-known companies like Hortifruit and Driscoll's that they sell specific blackberries that are of higher sugars compared to other conventional blackberry cultivation. So the ideal scenario, and I think this is not far from the future, you can go to a retail market and you can select blackberries of high sweetness, of low sweetness, or of limited sweetness, or more acidic, depending also on the consumer's perceptions and preferences. The color is another issue. Everyone knows that the red, and in particular the super intense red strawberries, are quite acceptable in some specific regions. This is an example that I can share you my experience, that I know that the Greek strawberries receive attention in some specific countries that they want the super intense red color. At the same time, we have differentiation in color. We have some cultivars, as you can see, that they are white fleshed, they are appealing in the eye, but the other issue is not just to be appealing in the eye, it is important also to be of high quality standards in terms of flavor and taste. In that slide, you can see actually a physiological disorder. There are some blackberries that they have this color reversion during cold storage. This is a disorder, it's more genotype related. And if you have this phenomenon, as you can see in the left part, this part can be rejected by the retailer, or it should be sold for a lower price into the market. In the United Kingdom, we have the ugly fruits movement. Actually, this is a very nice approach in order to reduce food loss and eliminate food waste. So actually, they are delivering fruits that are not uniform size. They have some defects for a much lower price into the market. And also, you can see on the left of my slide some premium quality fruits, very nicely presented into the box. But on the right, you can see in shelves of UK retail markets, fruits to be sold the higher quality in the highest shelf, the medium quality, the medium shelf, and the most or the low cost strawberries of inferior quality in the lower shelves. So this gives the consumer the possibility to buy according to his or her budget or according to what quality they are interested in. Greece, since we have many partners in this consortium from Greece, and also Cyprus is a Greek somehow connected very tightly with Greece. I would like here to present you a real success story of Greece, and this is a link to the strawberry cultivation. Nowadays, we are talking for a more than 200 million euros value business that is located in the area where is the coordinator of the FRIETS project in Peloponnesos. For those who are not familiar, it's in the southern part of Greece. The production is spanning from mid-November to late May. It's actually one of the earliest sites in South Europe, and this early production receives very high prices in the market. And what is surprising is the fact that from 160 hectares in 2003, in 2013 went to 1,000, and nowadays we're talking about 2,300 hectares. Actually, there is an exponential growth in the cultivated area. Nowadays, we have more than 300 growers, and it's important for the Greek economy, considering the fact that nearly the total of the production is being exported. And the success story of Greek strawberry sector is due to the fact that the production is being conducted in old beds, as you can see on the slide in the picture on the right. It's an environmentally friendly approach. You do not need to change the plastic black cover every year. This plastic cover offers through solarization. We have the disinfection every year. They used appropriate resilient varieties to temperature extremes. There is a high level of expertise of the people in this region, and the production, the analysis, the fertilization, the irrigation, everything is done not based on the eye, but based on actual measurements that are taking care the farmers real time into the farm. And again, here the production model is being based in two cultivars, Fortuna and Victory. Fortuna is receiving, providing the very early harvested crops by even from November, and these strawberries are receiving very high price into the market, while Victory is a cultivar that is having excellent post-harvest performance. So such fruits can be marketed for more than a week, and it can reach also distant markets all over Europe. So I will try again to speak with some facts and figures. So in an exercise that I have done, speaking with some experts in the area of strawberry production from stakeholders, the Fortuna production model, Fortuna is a very delicate cultivar, so you need to be a very well-skilled farmer in order to cultivate this crop. The annual production cost is about 65,000 euros per hectare. If you harvest 150 grams per plant from November to early January, you can sell it for 3.5 euros per kilo. Then the farm gate price, of course, decrease, but you can harvest more, about 850 grams. So in total, calculate 1 kilo per plant. This is the target. If we make the calculations and the math, then we can say that you can have from this investment, it's of course it's a good, but at the same time a realistic scenario, nearly 50,000 euros profit per hectare. And these numbers made a lot of people to invest in this cultivation in Greece. Moving now to blueberries. Blueberries is a quite different crop because the plant, you grow it for 10 up to 15 years. It's not like in raspberries and strawberries that you have to change it on a yearly basis. In the case of blueberry, there is a revolution. Just to give you some facts and figures also here, within 1 decade, we have 44% increase in the hectares being cultivated. This is a great increment. It's all over the world. Europe is not so big player. And here I would like to highlight that the biggest player all over the world is Peru. Peru was nowhere 15 years ago. But due to the mesoclimate and some investments, it managed to be nowadays #1 area of blueberry production for a number of reasons. They use, besides the mesoclimate, they use anti-hail nets. Big companies run huge establishments. I mean, 2,000 hectares, a single company. I spoke with some experts working in companies that they told me that we build schools, we build hospitals in order all the people around this area to cultivate these huge areas and big numbers of hectares to have everything needed in order to be able to be efficient in their work. And such crops arrive in the European Union through Rotterdam. And in that case, post-harvest is not a big issue in the sense that from harvest to consumption, it may take up to 40 days. And in the past, in collaboration with the University of California of Davis, we have conducted a study in order to increase through sulfur dioxide fumigation, followed by control atmosphere. We managed to expand the post-harvest window of blueberries by 5 weeks plus 3 days in the shelf life. And of course, instead of doing air transfer, nowadays we talk mostly for sea exports. Of course, this is quite old picture because Argentinian blueberry that was used to be a big business, now it's out of the market because Peru dominated for a number of reasons, and so a market available in Argentina has been disappeared. Now, at Cyprus University of Technology, we try to develop cost-effective production models and extend the availability period at technological level. And at level of basic research, we try to dissect the efficacy of priming agents as a means to combat abiotic stress conditions. We worked in this subject together with my collaborator, Professor Fotopoulos, plant physiologist, on the effect of priming agents. This is a graph and a heat map when we apply different molecules with priming effect in plants from a very successful PhD program conducted and finished 12 years ago by Dr. Anastasios Christou. And after that, since 2014, we started working in the setups linked with raspberry and strawberry mainly. And since 2024, together with partners from all over Europe, we are running the primes of the project that I will elaborate in detail in my next talk. So I will move forward to be on time about what we are trying to do. Basically, our challenges in specific for raspberry cultivation is to try to establish production protocols adapted to Cyprus microclimate, to mitigate climate change effects through the application of priming agents, to explore new cultivation techniques for off-season production, apply life cycle cost analysis to add value in the product for the local market, and enhance the cold chain management from the field to the consumer. Thank you very much, and I'm at your disposal if you have any questions.
Thank you very much, Professor Maganaris, for this great presentation and this insightful information that you provide us about the berries value chain. A lot of the issue that presented, it was unknown to the wider audience and especially to the consumer. So you gave us fundamental information on berries cultivation and the market insights. This is very important. Does anybody from the audience have specific question to address to Professor Maganaris? No, I cannot see anybody. So now we can proceed with the next part of our webinar, which follows the presentation of Professor Maganaris about the challenges and opportunities in berry sector by the innovation, the solution that the FRIETS project gave to the berry value chain. And we split it in 3 different steps, starting from the cultivation, the post-harvest treatment, and the final treatment in order to develop final products with high nutritional value, high quality, and extended shelf life. So the first presentation would be presented by Panagiotis Fratsis, which is a researcher in Agricultural University of Athens, and he's going to present us the precision farming for berries enhancing crop yield and quality. Panagiotis, the floor is yours.
Thank you very much, Sophia. So I will share my screen. Yeah. Can you see my screen?
Yes, perfect.
Okay, great. So hello again. My name is Panagiotis. I'm a research associate at Agricultural University of Athens. I know my presentation is a little bit large, so try to be as possible. So, okay, my presentation is divided into three sections: the introduction, the aim of the study, and the results and the next steps. So let's continue. Let's start with what precision farming is. Precision farming is an agricultural method that relies on data and technology, including sensors, GPS, and AI to optimize resource use, such as water, fertilizer, and pesticides, in order to enhance efficiency, productivity, of course, sustainability. The technology that is usually used in precision berry farming includes sensor, soil moisture, nutrient, and canopy reflectance sensor, drones and drones that from image processing can detect plant health, diseases, and growth variation, and automated irrigation and fertilization machines for variable rate application based on real-time data. In our case, we use the two first categories of sensor and drones. Let's see the benefits of precision farming for berries. Some advantages: higher yield and quality is to optimize nutrient and water management for berry size and flavor enhancement. The resource efficiency to reduce water, fertilizer, and pesticides in order to lower cost and environmental impact. The early detection of stress and disease by using AI analysis to prevent crop losses, and climate resilience from decision from data acquisition to mitigate the effects of temperature rainfall variability. Here you can see the robust fruit production in Cyprus. Cyprus is where our study was held, and the location of the robust fruit in the country. Cyprus has a specific unique climate that is divided into two climate zones. The hot Mediterranean, as you can see in red, which is around the coast with lower altitude, where 8 growers and 2 hectares of robust fruit fields are located, and the cold Mediterranean, where our study was held, and with a higher altitude, including 5 growers and 3 hectares. Let's see more specifically about the Cyprus unique climate. The most, let's say, the most comments I can say about the climate of Cyprus is the high altitude, the spatial temperature variation within the 70 kilometers of radius. So have a lot of temperature changes. So let's see more specifically about the two subclimate zones that I referred before. At the mountain climate, which is mild Mediterranean, includes altitudes of 800 to 1,200 meters above the sea level, and temperate cold winters that ranging from 1,000 to 1,600 CU. The mild summers that average 25 Celsius degrees, and the rainfall of 80 800 to 1,300 millimeters from October to May. And the coastal mainland climate, the hot Mediterranean, which has altitude from 0 to 500 meters above the sea level. It includes mild winters of 0 to 500 CU and very hot summers, averaging 33 Celsius degrees. Yes. So here are some climate data from meteorology located in Candria in Cyprus, where our study was held. We can see the air temperature that during summer period reaches max value of 28.05 Celsius, and the soil temperature that reached in August the value of 21.88 degrees. Yeah, also you can see here the annual percentage of the air relative humidity. Okay, let's continue with the soil moisture, where we see during the summer period the soil moisture reaches the minimum, which is 10%, which is quite low, and we can see the same reduction in October after the max value that it reaches. And also in soil, you can see here in soil base call. Can you hear me? Yeah, actually, can you hear me?
Yes, yes.
Yeah, I'm sorry, I have internet. Sorry. Okay. And here we can see the daily precipitation during the year of 2022, where our study was held, which averaged 0.08 millimeters, which is quite low, and reaches almost zero during summer. So the aim of the study is firstly to characterize the three different cultivars, specifically raspberries, Kelly, Mara, and Wenji, from the aspect of vegetation, number of leaves, lateral, suckers, flowers, and berries, and from physiology aspect, from spot measurement and DVI, stomatal conductance, chlorophyll fluorescence. And secondly, to identify when and how to predict yield by monitoring the temporal and spatial variation of the crop vegetation indices status during the critical stage of the growing season, and to develop a yield prediction model by investigating correlation between vegetation indices, soil and irrigation parameters, meteorological data, yield, and quality characteristics. Here you can see some photos from the pilot of the facility of the pilot in Cyprus. And here we can see the description of the structure of the pilot. The three varieties are planted in open field of 25 replicates, 5 groups of 5 replicates in the 10-liter pots with 5 pots per meter and 1.8 meters row spacing and 4 liters per hour drip irrigation. Here you can see some photos of the sensor we used in order to complete our study, such as the green sticker, the barometer, the fluorescence meter, and of course the drone. Here we have some information about the benefits of the drone UAV in agriculture. UAVs allows the fast acquisition of very high resolution data throughout the year. Of course, if light conditions allow it, because we have some challenges about the weather, the rain, and the wind speed. And they are the means by which a sensing instrument, usually camera, travels, offering remote imaging as well as contact velocity motion. And of course, drones can mount it RGB multispectral and thermal cameras that offers data with accuracy. Here are some indices that we use in our study. The well-known NDVI index, which determines the density of green, ranging values of -1 to 1. And here is the acquisition that we use in order to measure the NDVI. And the SPAD chlorophyll index, that includes the optical density difference at two wavelengths, 650 nanometers and 940 nanometers. And instantly measures chlorophyll content or greenness of the plants on scale or -9.9 to 199.9. Here we have almost some of the definitions about stomatal conductance, which include the measurement of stomata opening, and it's directly related to photosynthetic rate and CO2 absorption. And the chlorophyll fluorescence, which minimal fluorescence state is defined as the time point where chlorophyll associated proteins and other pigments absorb light, and maximal fluorescence when occurs when all chlorophyll antenna sites are excited from saturation of flashlight, and we can identify damage to the light harvesting complexes as the decrease in deviation of FV and FM. So let's continue with the results. From the canopy parameters chart, we can see that specifically Imara has developed more laterals that Kelly and Wenzi that indicate the potential to be the potential of vigorous growth. And also we can see the cane height chart that we have similar values in the height of the three varieties. We continue with the flowers chart, where we can see again that Imara developed more flowers in comparison of Wenzi and Kelly. That also indicates the potential vigorous growth, and we can see some similarities on cane's width. As for stomatal conductance, we can see that Kelly displays biggest values that indicates a better water availability. As regards to the photosynthetic capability, you can see from SPAD and chlorophyll fluorescence that the post charts indicate that Wenzi has better photosynthetic efficiency. As concerns the yield, we can see that in the first two charts that Kelly produce more berries from Wenzi and Imara, and you can see that Wenzi produce largest berries with more weight. Also here we can see that Kelly produce more from the yield chart. And let's continue from the NDVI that was measured from a proximal sensor, specifically from green seeker, where we can see that our three varieties has a very similar NDVI values. And let's continue to the vegetation indices from drones that we acquire from drones. And here are 5 vegetation indices that we used in order to see which of these of these indices has a bigger correlation with berry weight and number of berries in order to produce a prediction model. From our results, we can see that NDVI and GNDVI has a largest correlation. So it's more possible to be used in order to create our prediction model. So concluding remarks, we can see that Kelly and Imara have a higher transpiration rate and they are more vigorous in open field mounted production. But Imara promotes vigorousness to fruiting laterals. Kelly pushes vigor into cycle production. Aerial NDVI correlates very well with yield at peak season time, as you can see from our previous chart. Wedgie has a higher berry size, and Wedgie has better photosynthetic efficiency despite the lower transpiration rate. And the outcomes is to create vegetation indices-based models, predictive models for raspberry crops. High analysis vegetation indices-based maps of each crop field, which has the raspberry crops, and detailed monitoring, surveying strategy, documentation, and guidelines in order to promote replicability in different berry crops, such as blackberry and strawberry, and of course other varieties of raspberry. The steps that we're going to follow in order to produce the prediction model is to acquire multispectral images, and and with metadata we can you can use image alignment, and we continue with the point cloud, the dense cloud, and the orthomosaics that involve the map. And afterwards, we can calculate the vegetation index and to remove the ground of the map in order to have only the fruit in the map, and to use the masked vegetation indices maps. The next steps is the data collection for prediction model along with fruit quality parameters, the life cycle analysis of raspberries produced in Cyprus, life cost analysis of raspberries, and growth optimization protocol in 2 climates in order to have a different management according to the different weather conditions. Finally, I would like to thank all the people that contributed to this study. First of all, the Nicholas Valanidis, the founder of the Mountain Berries, that facilitates the whole study. Professor John Maganaris and Dr. Marta Basel from Cyprus University of Technology for their contribution, and my colleagues, of course, Nicoleta Adara and George Papadopoulos, and last but not least, the FRIETS project that give us the opportunity to do this study. Thank you very much.
Thank you, Panagiotis. Thank you very much for your presentation. It is impressive to see how many progress and the innovations that FRIETS project brought to this field of research area. So I would like to ask if anybody from the audience now has any questions to address to Panagiotis. No, so we can proceed now with Dr. Lavinia Kalinou from USAMV Cluj-Napoca, that she will present the innovative dehydration techniques for extending berries' shelf life. It is one of the major part of the research work in FRIETS project, since we consider, apart from the cultivation, the next step, that is the post-cultivation treatment, is extremely important in order to extend the shelf life of these extremely sensitive products, but without sacrificing the nutrient content and the final product quality. Lavinia, you can proceed with your presentation.
Thank you very much, Sofia. And I must say that I'm very happy to see all our partners present today here, and also our colleagues from the universities, from our collaboration with the economic environment. It's very nice having you all here. And of course, it's my honor to be a presenter along with Professor Manganari, with Francis, with Alexandra Mari, and also our collaboration with other Marie Curie projects like RIA for Food and PrimeSoft. I am honored, and as you mentioned, Sofia, of course, the next logical step in this project was to try to offer other technologies or methods in order to increase the shelf life of these precious berries, which provide us such a great nutrient intake and bioactivity, of course. So please let me know if I have my presentation in full screen.
Yes, Lavinia, it is in full screen.
I'm very happy. Thank you. So I will continue presenting innovative dehydration techniques for extending the mentioned berries' shelf life. And together with my colleagues and our partners from the National Technical University of Athens, the coordinator, the representative of RESOS, and of course, my colleagues from the university, we are happy to present you several innovations in terms of dehydration techniques. And one of them we acknowledge that is quite new also for us by using an integrated approach and combining the osmotic dehydration with the freeze drying technique, which we must say that provide interesting and valuable result. It has a great potential. This actually work package focused on optimizing the dehydration processes. And the first one was the osmotic dehydration process, followed by a development of osmotically pre-treated high added value berries containing functional compounds. The next step was to optimize the freeze drying and the microwave vacuum drying processes, all of them followed by a proper evaluation of the dried products obtained. Our three main tasks where also National Technical University of Athens got the leading, and together with us, we succeed to provide a great set of results coming from these experimental parts. I will start with the first dehydration process proposed and evaluated and validated, of course, the osmotic dehydration. What does it actually means, this type of technique? Actually involves food preservation, and it uses the removal of water from the food materials by immersing them in a concentrated sugar or salt solution. Well, actually, the driving force behind is the principle of osmosis. What is extremely relevant is the sustainability aspects behind the low energy consumption and the preservation of the texture, of the taste. Moreover, in case of using different concentrated sugar solution, we can improve actually the taste of the dehydrated products. So First step was to optimize in lab scale these techniques on all type of 4 berries: blueberry, raspberry, blackberry, and strawberry. There were proposed several osmotic solution like sucrose 50%, glycerol 50%, apple juice 50-degree brix, the combination of apple juice with glycerol, and of course different other combination like apple juice and pectin, depending on the matrix. Was extremely relevant also to propose different fruit to solvent ratios. And the ones that were investigated are 1:2, 1:5, and 1:10. And of course, different temperatures like 25, 40, and 55 degrees. The time was actually constant here, the process being monitored during 24 hours. This is actually how it looked in terms of experimental stages. And these are actually the osmotic dehydration graphics, which provides us with insights regarding the percentage of dehydration at different temperatures and with the ratio of 1:5. In the end, the optimum condition of osmotic dehydration in lab scaled supported the premises of ratio 1:5 and temperature 40 degrees in the case of all type of berries. And the time, of course, expressed in minutes here, is 8 hours in a case of blueberries, and 6 hours in case of the other ones. And regarding the solution, the osmotic agent, it varied depend on the berry type. So for the blueberries, we have the apple juice as the best candidate. For raspberry is the combination of apple juice with glycerol besides the apple juice, which is also the case for the strawberries. The optimization step of the osmotic dehydration process involved also the addition of bioactive components doing the osmotic dehydration. And the bioactive components used were provided via rosemary extracts, which actually were added in the process. And there were 3 different concentrations tested. Of course, the evaluation was done for all type of dehydration methods after all the optimization steps. And in this case of adding bioactive components involved the bioactive diffusivity, the antioxidant activity, and of course, the most important and sensory characteristic of the final products. In terms of bioactive diffusivity of raspberry with addition of bioactive components doing osmotic dehydration, we can observe that there were different behaviors involved. And regarding the antioxidant activity, depending on the concentration, it varied. And the best one is the concentration of 1% rosemary extracts measured by the IC50 value. In terms of sensory evaluation, we can see from the graphics alongside that the dehydrated fruit was actually equally accepted with their fresh counterparts. Of course, the osmotic dehydration process in lab scale was followed by an optimization step in the pilot scale, where we have different parameter and specification of the pilot scale units, as is illustrated on the slide. The osmotic solution used are the most suitable ones from previous lab scale analyses. The apple juice, the glycerol in different concentration, and the sucrose in different concentration, and only 2 type of temperature tested, 25 and 45 degrees. What is extremely interesting to observe in terms of pilot scale optimization is the water loss, which actually depended on the ratio of the fruit to solvent. So the water loss actually ranged from 9 to 30%, and the solid gain ranged from 2 to 9%. The better results were shown by the apple juice and the combination of apple juice with glycerol compared to sucrose. A longer duration, of course, resulted in higher water loss and solid gain, with no significant differences after 120 minutes. And the fact that we tried to use also an increased fruit to osmotic agent ratio from 1 to 5 to 1 to 3 to 2 actually showed us a decreased water loss and solid gain. Therefore, the best ratio is 1 to 5. So here are also the illustration of the optimum conditions. The ratio 1 to 5, as already mentioned, temperature 45. In case of blackberries, the temperature should be more increased, around 65, 68 degrees. And the time, of course, depends on the type of berries and also the osmotic solution used, but predominant being the apple juice. As general conclusion regarding the osmotic dehydration process in lab scale and pilot scale, this type of dehydration process is favored by an increased temperatures, of course, and by an increased osmotic medium concentration. Higher values for water loss and solid gain were obtained when employing apple juice and glycerol as osmotic agents. The optimum results are, of course, depending on the type of berries. In terms of blueberry, the apple juice was the most suitable one, with a temperature of 45 degrees. In terms of raspberry, the combination of apple juice with glycerol and apple juice itself at a temperature of 45 degrees. In terms of blackberry and strawberry, we had the same osmotic agent, namely the apple juice, and the same temperature, 45 degrees Celsius. The next dehydration technology was the microwave vacuum drying. Actually, this process involves the drying via the heat that combines the microwave heating and vacuum technology. Several advantages of this technology: faster drying times, energy efficiency, and the preservation of product quality. The principle behind is actually utilizing the microwave radiation to heat the material while maintaining a reduced pressure environment through the use of vacuum. So here are the graphics illustrating the drying process via the microwave vacuum drying. So the moisture content gradually decreases, indicating the removal of water, decreases in time. The third technology that we used and validate was the freeze drying. This method is effective for high water removal, just like in the case of berries, where the water content is quite high, over 70–80%. Of course, it's a way of preserving the fresh fruit characteristic. The process is based on the freezing of the product, followed by sublimation of the ice at reduced pressure. In terms of optimizing the freeze drying and the microwave drying, there were several parameters that we have monitored during the optimization. For the freeze drying was the moisture content and the water activity, is the removal of the water. And the parameter that were adjusted was the pressure and the temperature. In terms of microwave vacuum drying, of course, it's the chamber rotational speed, is the power, and the pressure that has been used. And there are several pictures illustrating the lyophilization of the or the freeze drying process, because the second common name used for freeze drying is lyophilization. So in the next slide, you may as well follow this terminology. So in terms of the freeze drying optimization, we have monitored the water content of all type of berries by weighing the weight before and after the freeze drying. So we have noticed a very high efficiency in removing the water from each type of berries. The innovative aspect of the freeze drying optimization process was the use of the integrated approach of combination between osmotic dehydration and the freeze drying technique. So in the next 4 slides, we will also observe 3 different type of data of lines in the tables. First illustrating the fresh strawberry, second the osmotic dehydrated strawberry, and the third the integrated approach of combining the osmotic with the freeze drying. So as we can see for the strawberry, this combination of osmosis with the freeze drying is actually the best in water removal, ending up at around 6% of water after using this combination. In terms of the blueberries, is the same efficiency, high efficiency. We ended up at around 9% water after using the combination of osmosis with the freeze drying. In terms of raspberry, more or less the same. And of course, in terms of blackberries, we received the same high efficiency in removal the water. So as general conclusion, this freeze drying offers a very convenient and nutritional alternative to fresh fruits, with benefits such as extended shelf life, preserved flavor and aroma, and versatile application in various food products. Of course, it helps in retaining the nutritional value, the aroma and the flavor, and of course, is in line with the consumer demand for natural and healthy foods. The third main research direction was to evaluate all these dried products. So the evaluation was based on measuring the total phenolic content, total flavonoid, total anthocyanin content in different biological activities, including the antioxidant ability of the dry products via different methods. Of course, the monitor of microbiological load by the presence of pathogen or no pathogen and spoilage microorganism rates during storage. And the most important is the sensory evaluation. For the osmotic dehydration process, we have also measured the total solids, the total acidity, and of course the antioxidant activity by the IC50 values. And the first case, the first analysis presented are for blueberries. And of course, we have also the colorimetric measurements in terms of sensorial analysis. We can see that for blueberries, the highest antioxidant activity, the IC value was obtained in glycerol as an osmotic solution, 0.15. And in the right side, we can see the total acceptance and the aftertaste of the osmotic berries, of the osmotic blueberries, which actually has equally acceptance as their fresh counterparts. The raspberries have a bit different sensorial evaluation compared to the blueberries. And in terms of total acceptance and aftertaste scored lower, around 5, around 6. The blackberries had a great scoring in terms of sensorial evaluation, reaching almost 8. That means very pleasant. And of course, the IC50 values are showing a potent antioxidant activity of the dried berries. The strawberries succeed to have a great acceptance in terms of aftertaste, and of course a very pleasant taste, which was appreciated by the sensorial panel. The freeze drying products were also evaluated in terms of phenolic composition using the liquid chromatography. And in all 4 cases, we can see a very concentrated product in terms of phenolics, which is great considering that you can eat 1 strawberry, for instance, and get such a high content of phenolics. In terms of antioxidant activity and the viable cell count, that means the microbiological load, we can observe, of course, due to the concentration of the phenolics, a higher antioxidant activity measured on the dried berries. In terms of microbiological load, we can observe that the dried berries had a longer shelf life with lower microbiological load in time, tested in after 7 days. Of course, we have continued the evaluation, also measuring the total phenolics, flavonoids, and anthocyanin content with the standard methods, like Folin Chocolteau for the phenolic content. And it was confirmed again that due to the concentration, the water removal, the lyophilized, the freeze-dried samples experience a higher concentration of phenolics, flavonoids, where was the case, and of course, anthocyanins. The total viable cell count in terms of molds and fungi was also illustrated via graphics in order to be more easily to observe actually the viable cell counts. And they are in the standard according to the legislation, and the lyophilized form, the freeze-dried form, of course, preserve better the microbiological quality of the berries. The sensorial evaluation of the freeze-dried strawberry in this case, we can see the high score received, 8-9, which means extremely pleasant, very well perceived in terms of different sensorial attributes tested, like the aroma, the taste, the smell, the textures, and so on. So we are extremely happy with the sensorial analysis, also for the freeze-dried berries, and also for the osmotic freeze-dried berries, the innovative integrated approach of using both type of drying technologies together. So it's the same in case of the blackberries. It's score 9, which is the highest. And we have some general conclusion regarding the freeze drying. Of course, in all berries, the phenolic content and the phenolic composition increased after using this preservation, this dehydration technique. And it's normal to be like that, considering the water removal. Also, the antioxidant capacity increased. That means that it's gentle dehydration method that actually preserve the nutritional and the bioactivity of the berries. The total viable counts for fresh fruits increase after 7 days of storage, but in terms of dried fruits, it actually decreased after 7 days of storage, which is extremely relevant for us, considering the aim of this research, namely to increase, to extend the shelf life of these berries. I would like to acknowledge all the great contribution of the researchers from National Technical University of Athens, Alexandra Mari, who is here together with us today, of course coordinated by Professor Krokida. I would like to also acknowledge Rezo's contribution in terms of the pilot scale optimization, and all my colleagues who are here with us today from the University of Agricultural Sciences and Veterinary Medicine of Cluj-Napoca, and our mentor, Professor Vodnar, for these great experimental results. Thank you very much. If there are any questions, I am here to answer.
Thank you, Lavinia. Thank you very much for this great presentation. Does anybody from the audience has a question for Lavinia about the dehydration process of the berries? Oh, no. So we can proceed with a small change in our schedule. We are going to proceed with the presentation of Professor Maganaris and the presentation regarding the primes of the project. And after that, we will continue with the processing of the final product of berries. So, Professor Maganaris, please proceed.
Yes. Thank you, Sophia, for giving me the floor and for this amendment, because I have scheduled, I have another back-to-back meeting. So I will try to highlight that the primes of project that I'm coordinating is really tightly aligned with FRIETS. We have find and identify, we actually identified several synergies, and hopefully some joint work will be funded actually by both projects in the near future. So very briefly, I would like to highlight and bring into your attention some key issues about this project. It's a project that actually is ending actually the same period like FRIETS in October 2025. Besides Cyprus University of Technology, Sebas Esik from Murcia, Catholic University Leuven from Belgium, University of Potsdam from Germany, and National Technical University of Athens are being involved. And here the concept is how we can ameliorate the performance of plants under abiotic stress conditions, mainly salinity and the cold and heat, of course. And we aim to bridge the gap between chemical and nanomaterial priming. Priming, actually, it's actually the induction of some compounds at very small concentrations that can act sort of a vaccination for the plant, to give you an idea, in order to combat such conditions. I will go briefly, selectively, some slides, just to indicate who are the steering committee, myself, Professor Fotopoulos, Bert Muller-Robert from Potsdam, Martin Hertog, expert in computational analysis and modeling from Leuven. Sebas Esik is being represented by Francisco Thomas Barberan, a global expert in metabolomic analysis with special reference to polyphenolic compounds, and Professor Krokida from Athens. We have set up a scientific advisory board comprised from people both from academia and the industry. And we also set up a users group because we want to communicate all our data and results to companies in order to have an exchange of knowledge, and also these companies to be at the first stage indirectly or maybe directly in the future, hopefully being benefited from the results that will be generated by this proposal. We have an extensive area of activities related to dissemination, communication, exploitation. I will go very briefly to indicate you that we have a very active LinkedIn page with more than 1,000 followers. So I would like further to advertise this website. We provide not only the activities, but additionally main findings from our research activities. So you can go and scroll down and find what we are doing in this account. We have also newsletters being published on a yearly basis that are available online in a flipbook format as well. And of course, promotional material, and actively being engaged to research nights back to 2 years. We provided such information for the general public, including pupils from the elementary and secondary school. The aim is to publish in high-impact journals. Just to give you an idea, our flagship is this work in Trends in Plant Science, that is a top-class journal in the sector of plant sciences. We have also technical articles being published in journals, and I have also the privilege to deliver several keynote talks in highly esteemed conferences. One of them was a conference in Rubus and Ripe's symposium in Portland, as well as some other more technical conferences that they attract a lot of people from the industry. We organized an international workshop last November with 34 speakers. Actually, we transformed the workshop to a conference with a book of abstracts, 34 speakers, half from academia, half from the industry. And I think this was one of the highlights of our work. We also focus on the training and mentoring of early stage and experienced researchers. To this same, several workshops have been organized. And additionally, we organize training schools in all our collaborators in Potsdam, in Sebasesik, in Leuven, and additionally in Athens. All the information about what we are doing, what were the main topics discussed from these training schools are available in the website of the project. And also we focus on research and innovation activities. For the sake of time, I would like to highlight that we worked on spraying strawberry plants and particularly fruits at different developmental stages. And in that case, the working hypothesis was to see if pre-harvest application of such agents can enhance the phytochemical performance of the fruit crops. We also applied experimental approaches at post-harvest level through immersion to different formulations. And the most challenging and quite difficult in terms of implementation experiments dealt with the fact to apply stress-related experiments, I mean apply salinity or drought. So we took the plants, in tray plants, we applied the agents in the root zone initially, and then during the first developmental stages, so as to see how they perform. This was in strawberries. So here you can see a tray plant of strawberry. This is the tray plant that I discussed before that is being sold nowadays about 30 cents per plant, just to have an idea. And these small raspberry plants, because they are with the quite expensive royalties, being sold for €1 per plant. And in that case, you can see that we apply the priming agent, sort of a vaccination, I would say, directly into the soil in order somehow to try to reduce the stress during transplanting, from transforming this from the tray plant to the soil. We, thanks to SESIC, we have the opportunity to have a metabolomic analysis with an array of phytochemicals. Thanks to Leuven, we became familiar, and we brought now in-house how we can perform a high-profile analysis regarding aroma profile of fruit crops. And I'm also very happy that through this project, I had the opportunity to fund Dr. Egli Georgiadou, Dr. Elena Mirci, Research Assistant Sofia Toronda, PhD Anna Maria Taliadoru, and of course, Nicolas is independent and is benefited from this project in the sense that some of the data published hopefully will be part of his PhD project. So I was very brief, and I hope that I managed to convey the main message from what we are doing and how PrimeSoft is connected with FRIETS. Thank you, Sofia.
Thank you very much, Professor Maganaris. This PrimeSoft project is one of the most successful case studies of collaboration of teams between research projects since starting from FRIETS. Some partners and members of the same team, they continue the collaboration through PrimeSoft, and I'm sure that this collaboration will continue with next research projects also. I think now we can proceed with Alexandra Mari, an early stage researcher from National Technical University of Athens, that will present us their work on edible coating application for berries, improving post-harvest quality. Alexandra, the floor is yours.
Yes, hello everyone. Let me share my screen. So if you please can confirm that you can see my screen.
Yes, yes, it is there.
Perfect. So hello everyone, I am Alexandra Mari. I'm from National Technical University of Athens, and I will tell you some things about edible coatings and how we applicated them on berries in order to improve their post-harvest quality. So berries, as we have mentioned in the previous presentations, are high persistable and they deteriorate quickly after harvest. They are fruits with a high nutritional value, with many vitamins and antioxidants and nutrients. However, they rot really quick and their shelf life is not really long. So that is not feasible economical because they are quite expensive, and it is the food industry's work to find a way to minimize the losses, benefiting the farmers, the distributors, and the retailers, in order to lead to a more sustainable way of eating berries. So the basic challenges in the berry preservation is that they are really, it's really easy to lead to microbial spoilage and moisture loss. The impact of temperature plays a great role on their quality. The berries are overproduced during the peak seasons, and then they need to be distributed and eaten, or they will be rotten. So there is an imbalance between the supply and the demand in the off seasons. And there is also a lack of proper storage and transportation systems in order to preserve them properly. They are really high, they have a high water content. They are sensitive to the temperature fluctuations. They are vulnerable to microbial contamination. And also there are problems with mechanical damage during the handling and their transportation. So edible coatings are a solution and an environmental friendly solution that can help solve some of these problems I mentioned before. It is a thin food safe layer applied to the food surfaces in order to preserve the freshness, to extend the shelf life and enhance their appearance, while protecting against moisture loss and spoilage. So when we applicate the edible coatings to the fruit, they seem to be preserved better for a longer time. So the key benefits is that their shelf life is extended, the moisture loss is reduced, as well as the microbial spoilage. The quality, is also enhanced, as the taste, the texture, and the color are improved in many cases. Also, it is a sustainable solution, as it is an alternative to synthetic preservatives. So the berries that are treated compared to the untreated berries present lower microbial spoilage rate. As I said, improved texture and appearance, longer market availability, and they are protected from external damages. There is a high acceptance from the consumers as the coatings do not alter the taste. And there is also a rising demand for natural freeze-free preservation methods and sustainable solutions. So there are mainly four types of edible coatings. They are from polysaccharides, from proteins, from lipids, and they are also edible coatings from the combination of these three components. It depends on what do we want to achieve and what the food product is. So the nutritional value is improved, the moisture loss is decreased, and the shelf life is extended. There are three application methods. It's dipping, spraying, and brushing. They are different, and it depends again on the food product we want to applicate the coatings. So there are some limitations and challenges. Depending on the coating, there may be some taste alterations. So it's really important to make sure that the edible coating does not change the taste of the product. Sometimes there may be high production costs, which lead to scalability challenges, and they rise the final cost of the total product. And also there are safety regulations sometimes that need to be addressed. So in FRIETS, we developed alternative coatings from algae and compared them with conventional coatings. We used microalgae and macroalgae in order to develop these coatings. We optimized these edible coatings regarding physiochemical features, water and vapor permeability, thermal properties, and mechanical properties. And then these coatings, we applicated them on berries to see how they affect the shelf life. So we used raspberries, blackberries, blueberries, and strawberries, as we have mentioned before. We applicated the optimized edible coatings and investigated the methods I mentioned before. So here you can see some photos from the process. And we also added bioactive compounds to see if there's a difference in the microbial spoilage. So the basic results we have from this study is that the waste loss was reduced through storage, and it was significantly reduced, which means that the berries were preserved better through the days. The diffusion coefficient was really lower, which means that the moisture loss and the water vapor transmission was really lower, leading to really good results for the shelf life. And also the microbial count was significantly reduced, leading to results for blueberries at 21 days. The fresh blueberries were not okay to eat because they had exceeded the microbial limits. However, the coated berries were totally safe, and especially the Hitozan edible coating led to the best results regarding microbial count. So some future perspectives on the edible coatings is to examine nano-enabled edible coats, the development of smart coatings that can also monitor and respond to environmental changes, the infusion with other preservatives, antioxidants, and ingredients. So there are many things to study on edible coatings, either on berries or other food types. And it's a really sustainable and interesting solution for the food industry in order to extend the shelf life of some products. So that's all from me. Thank you very much.
Thank you, Alexandra. Thank you for the great presentation. As you saw, it is a very challenging issue to maintain the quality and extend the shelf life. But as you presented, the edible coatings can be a case that can be a promising solution on this issue. Of course, further studies are needed on that, and this is something that could be a case of future research collaboration to focus mainly on the quality of the final product and the extension of the shelf life. Does anybody from the audience has questions to Alexandra? Okay, so we can proceed with the fourth part of this webinar and the presentation of FRIA for Food and Sakami project. I kindly ask from Dr. Amalia Nemes from Inspire Science, as a dissemination manager of RIA for Food project to present this very interesting project to us.
Yes, hello Sophia, hello everyone. Can you see my screen?
We can see your screen, Amalia, but we cannot hear you very well.
How about now?
A little bit better.
Better.
Now it is great.
Is better?
Great.
All right. So no problems. So hello everyone. My name is Amalia Nemes, as Sophia introduced me before, and as the dissemination manager of the RIA for Food project. In the next few minutes, I will make a brief presentation of the project, and I will briefly present to you the main activities and the events that we have. Here is a short structure of my presentation, including an overview of the project, the work packages, the project timing and partners, and where you can find us on social media and on events. RIA for Food project suggests a framework for valorizing multidisciplinary technologies to design food products with scientifically proven functionality and health benefits. The aim of the partners is to create an international cross-sectorial and multidisciplinary partnership between farmers, academia, research and technology organizations, and companies outside the agri-food sector in order to facilitate the uptake of innovation in the field of functional and healthy food development. The project is using Cibacton berries, which are a potential source of many bioactive compounds, including vitamins, carotenoids, phytosterols, fatty acids, flavonoids, and many more, using methodologies applied for analysis that are part of chemistry, biology, food biotechnology, and computer engineering disciplines. All of those having as purpose the development of a functional food product which can sustain the nutritional needs of all consumer groups. The project focuses on four main directions. The first of those are represented by precision agriculture sustainability, performed at the Hippocrates farm in Meteora, Greece, where Rezos, our coordinator, is applying organic cultivation of Cibacton berries, combined with the principle of precision agriculture. The second direction is the evaluation of Cibacton metabolomics that includes the identification of the human physiological pathways affected by the Cibacton consumption at the molecular level. The next direction is the osmotic dehydration in order to develop a healthy dried product with increased shelf life. And the last one, of course, is, and the most important one, is the design of a functional food with increased nutritional content and specific health benefits. The work packages of the project, as you can see on the slide, the first work package involves a metabolomic profile of fresh and osmotic sea buckthorn, followed by the work package 2, involving evaluation of fresh and osmotic sea buckthorn effect on in vitro human relevant disease models. Work package 3, that is about the association of sea buckthorn metabolomic, epiproteomic, and proteomic signatures on human physiology, followed by 4 more work packages, which are the work package 4, evaluation of new functional food products of health benefits, the work package 5, which is about the sustainability assessment, followed by, of course, work package 6 about dissemination, communication, and impact strategy, and the project management with the work package 7. The project started on November 2023 and will last until November 2026. And the project leader is Rezos Brands from Greece, from Patras. Their integrated approach covers cultivation, research, processing, and distribution, offering a high quality and innovative products with a particular focus on precision agriculture and sustainable processing techniques. Our collaborative initiative brings together a group of partners across 4 European countries, as Greece, Italy, Cyprus, and Romania. RIA for Food project brings together researchers from universities such as University of Patras, University of Agricultural Sciences and Veterinary Medicine from Cluj-Napoca, Romania, and the University of Piemonte Orientale from Italy, along with research institutes as the Cyprus Institute of Neurology and Genetics from Cyprus, and Alexander Fleming Biomedical Science Research Center from Greece, along with SMEs such as Rezos, Nova Mechanic, and Inspire Science. You can find us on social media in channels such as LinkedIn, Facebook, X platform, and of course YouTube, where we invite you to subscribe and to follow our progress. Our communication channels are maintained always updated with our last activities, including the events where we participate. On the events, you can remark us with our official prints that are bookmarks and flyer, as you can see, and of course our brochure. In the end, I am excited to announce that the next key event where the RIA for Food project will be presented is our very first workshop taking place on March 12th. This year at the conference of and cultural center of the University of Patras in Greece, where we would like to invite you all. This workshop will focus on presenting the research and innovation approaches for food functionality, and it also will be a great opportunity to exchange ideas and explore new advancements in the berries field. Thank you. I was very brief, and I hope that I increased your interest about our project, and you will follow us. I hope that you will follow us to see our progress.
Thank you, Amalia. Thank you very much.
Thank you also.
Again, Also, this RIA for Food project, as it was also the case of PrimeSoft, it is the proof that the good collaborations and the interdisciplinarity in research areas can bring next project and can open always new horizons of research, and this is also a successful case study of the continuation of coherent and fruitful collaborations. Now, the next project that will present it is Sakami project. I invite Ms. Liakopoulou, project manager of Sakami project from Rezos branch, to present the project.
Yes, hello everyone. My name is Paraskivi Liakopoulou. I'm a chemical engineer and a project coordinator at Rezos branch. I would like to thank you all for inviting us here today and the organizers of this event. It's an honor to be here today with you and to present the Sakami project and, of course, explore synergies within the berries value chain. The project Sakami, a partnership of a precision agriculture's optimum business model, exploitation and application in the Hellenic cultivation of Sybackthorn, aiming to the production of high nutritional value food products, is a national Greek project funded by the Agricultural Development Program, MISER 16, of the Ministry of Rural Development and Food in Greece. The project has many in common with the RIA for Food project, as it relies on
you are muted. We cannot hear you now.
I suppose you can hear me now, right?
Yes, yes.
Okay. So the project has main in common with the RIA for Food project, and this is very interesting as it relies on the cultivation of Sybackthorn. As you probably know, and Amalia described before, Sybackthorn is a plant cultivated in diverse pedoclimatic and geographical zones, and it's commonly known for its highly nutritious berries. They are rich in vitamins, antioxidants, omega fatty acids, and essential minerals. However, in Greece, Sybackthorn is cultivated to a limited extent, and this is mainly in mountainous and marginalized areas where farmers there lack of support from advisory organizations and innovation services. So the main challenge in Sybackthorn cultivation that farmers face in Greece, and this was the idea that Ernst the project from in 2017, is the exhaustion of soil resources. This, as you probably understand, organic matter and soil moisture are essential for the natural cultivation of Sybackthorn. Farmers use excessive chemical fertilizer, without properly studying the soil characteristics and the needs of each specific area of cultivation. This has many consequences. It leads to low quality and quantity of Sybackthorn production, and also reduces the economic efficiency of the agricultural crops. It also affects the environment due to the unsustainable farming practices that are being followed, and it poses as well health risks from farmers that are being from the chemical exposure. So the project here aims to apply precision agriculture technologies to Sybackthorn cultivation in order to restore agricultural productivity. By doing so, we aim to minimize inputs, of course, maximize economic returns, improve competitiveness, and protect as well the environment. The Sybackthorn berries that are being produced with precision agriculture technologies are being used in order to produce afterwards sea buckthorn berries products, and especially cereal bars enriched with sea buckthorn. Last but not least, the project aims to connect farmers with the food manufacturing sector, and as well we can say the research institutes. Our project started in February 2023 and it's expected to be completed in May 2025. It follows the path created by 5 work packages. Work package 1, which is research and development of an innovative business model of precision agriculture and targeted sea buckthorn cultivation. Work package 2, application of precision agriculture methods in sea buckthorn cultivation. Work package 3, which is the development and pilot scale production of a high nutritional value cereal bar enriched with sea buckthorn. Work package 5, which includes innovation, mediation, and facilitation action. And of course, work package 5, project management, dissemination of results, and ethical issues. The project involves 5 partners. The coordinator of the project is Aristotle University of Thessaloniki. It also involves 2 manufacturing companies, food manufacturing companies, Resos Brands SA as well as Iotis SA. And of course, 2 Greek farmers, Mr. Zafilidis Georgios and Mr. Panayotou Konstantinos. As the application of precision agricultural methods in sea buckthorn cultivation and as part of the activities that have been developed in work package 2, we have developed a mobile application in order to support producers managing and ensuring production quality. They can view real-time sensor values. It has the ability to generate daily, weekly, or even yearly reports. It as well create alarms for critical sensor, and you can secure farmers can secure that have access to data all time. It also incorporates an SMS messaging technologies to mobile phones, so producers can immediately get informed about any need for irrigation or even fertilization. At the same time, an information system for sensor data collection, management, and long-term storage has been also developed. This system is something like a cloud-based data repository that provides big data analytic and data visualization services. This significant data is something like a significant database for forecasting input needs and better planning production operational costs. An innovation hotspot, which is a platform for dissemination and innovation, has been developed as part of our disseminating and facilitating, let's say, activities in work package 4. It acts basically as a central hub for managing and displaying all project results. It is being used because it can be easily integrated into exhibitions, conferences, meetings, and everything, as it can display. You can display results on all type of devices in kiosk mode very easily. And in parallel, it has a management tool when you can store and manage all project research results. The project has 3 main communication channels. Except from our website, we have 2 profiles on LinkedIn, social media accounts on LinkedIn, and of course Facebook, where I kindly invite you all to follow us and stay updated on all our project developments and updates, of course. I was very brief. I want to thank you all. Of course, I remain at your disposal if you wish to discuss anything and of course explore further synergies within the projects.
Great. Thank you, Vivi, for your presentation. So we saw through SACAMI also the possibility to implement high quality projects with national fundings, if I am right. So This is also very important because all the knowledge that is gained through international collaborations and European projects, it is very important to be capitalized also in a national and local level by giving by stepping forward and also support these new research endeavors. Thank you all for your presentations today. As part of the final section of our workshop, our webinar, I would like to start a conversation where we can sum up and lead to the major conclusions. From your presentation today, what I noted, it is that there are still a lot of challenges, apart from all this work have been done within the presented projects, but also there are a lot of opportunities also. To my point of view, the main challenges that I notice is the most important, the product sensitivity in the berries value chains, especially in the storage, that makes extremely difficult the logistic chain. The high cost and labor demanding cultivation. That is something that could give some topics of further research, of course. The major opportunities that I saw, it is that the farmers turns to the cultivation of berries. As Professor Maganari showed us, there is an exponential increase in the hectares, especially in case of Greece, for the production of berries and strawberries. And also, it is important to valorize the new wave and the new generation of farmers that they are open on following green agricultural practices, and they are open to collaborate with the research projects and also to integrate in their conventional farming system all these innovative techniques and solutions that our research project propose. And as a final step regarding the final product, I saw that we should proceed as a researcher and in further collaboration and further project with more coherent business plans regarding the berries value chain, thorough market analysis, and also another issue that we can work on is the labeling and the certification of these products, especially since they are products with high export potential. The certification should be something that needs to be taken into consideration. This is the main issues that I came up with. As you have been informed previously from our project coordinator, Mariana Lagonikou, this FRIETS project, like also RIA for Food project, are projects that are funded under Marie Curie staff exchange actions. And this is very important because the difference of this type of project is that we support the mobility between researchers from industry to academia and vice versa. And this is extremely important in a project like this that deals with the primary production. It is extremely important to bring the researchers on the farm from the universities and also the farmers to see the research facilities in universities in order both of them to understand from the one side the researcher the real need, the challenges, and to highlight the hotspots in the production, in cultivation, in the production step, and also for the farmers to be informed in innovations and also to the state-of-the-art techniques that they can follow and adapt in their current practices. As a final remark, I would like to show you the opportunity to submit to the next call of Marie Curie Rice Project that will be open late of March 2025, and the application will be have a deadline of October 8th of 2025. So I hope that this webinar and this gathering can bring together stakeholders of the berries value chain, and can be the start of a conversation and maybe the start to build new consortium for the next Marie Curie Rice call. Now, if any of you have some remarks, something that you noted and you want to highlight through all this presentation, please, we'll be more than happy to hear your opinion. Yes, I saw. Yes, Dorian.
Hello, all right. So I'm Dorian from MJR Farming Limited in Malta. Yes, from the presentations, also would like to point out that for a small country that we are coming in Malta, we are facing also the difficulties of the lack of technology, which also will lead to higher labor cost and higher cost for the project, for the products. And well, yes, with the project with FRIETS, we can also learn more ways to use technology for precise agriculture, which it lacks a lot in Malta. It lacks a lot because, as we said, the farmers are very small, mostly are old, and they are afraid also to use technology. So it is very important for projects and for researchers to go in the farm. So it will be easier. It will be easier also for the farmers, and also to make the courage to use the technologies, which can help a lot in the yield and in the quality. So basically, I noticed the same issues in Cyprus as well, for the quality in the transportation, since it's a soft fruit. So yes, well, basically we need more help also, and projects to help the farming sector.
Great, thank you, Dorian. I think as you saw, as you mentioned, in general, in the Mediterranean area, and with the differences now also in climate and the increase of temperature, the challenges in berries production would be even higher. So all of this should be taken into account. Mariana, do you want to have a conclusion?
Yes, can you hear me?
Yes.
Okay. First of all, I would like to thank Dorian that mentioned a very important gap between farmers and researchers. And it's very important that he knows this problem and he is willing to participate in other projects in order to resolve this issue. And it's very difficult nowadays, the farmer, to know this problem and to try to resolve this by research, I mean. And I would like to thank all for your time and participation. Once again, I would like also to mention that I'm very happy for the FRIETS project and the results and the progress of this project, because there are a lot of work and dedication of all the partners and all these 3 years. And now this year we are in the last year of our project, and we continue to produce results even after these 3 years of collaborating. I would like to thank you all for your participation. And we are here, also Sofia and Dignity and Resos branch. If you want something further information about the project or the innovation that produced during the project. Thank you very much. And thank you, Sofia, for organizing this webinar.